The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. What is that horrible sound? It's like the souls of dead kittens thrown into a washing machine with Nickelback. Karen, Felix, what the heck is going on in here?
Oh, we're playing Super Mario Bros. 3 with a power glove. Oh, I think I got arthritis.
Don't worry, Felix. We'll amputate it.
Oh, please don't.
Karen, you seem to be doing okay with it.
Yeah, except I have to hold my arm up, and bending my thumb like this is really awkward to jump.
Well, there's got to be something the power glove is good for. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, like I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Hello and welcome back to the Ben Heck Show. I have to ask, why were you guys playing Power Glove?
Well, I do love me some gloves. Keeps my fingers all toasty. But actually, it's because we got a build suggestion on our Element 14 community from Brandon Griffith, who wanted us to do an upgraded version of the Power Glove.
Yeah, I heard the Power Glove wasn't very good for gaming because it's like this is left, that's right, up, down. Kind of pointless, but I've heard it can actually do more than that.
Oh, really?
Yeah, so I think we should give it another try. Are there any other things going on in today's episode?
Yes. In a Felix's corner, Felix is going to make his own radio controller for some certain fighting robots that we might be building in a future episode.
Oh yeah, and also regarding a future episode, I plan to do some research work on our futuristic space computer prop, so we'll do that as well.
Ooh, are we gonna reuse some of the pieces from our salvage episode in that?
Well, I already reused a piece from the salvage episode in the pill dispenser.
But we can reuse more!
Yes, we will definitely try. But for starters, we're going to play a game called Super Glove Ball, which apparently uses the motion tracking of the glove properly, and maybe that will give us some inspiration of what the glove can do.
Let's go play.
So this game is Super Glove Ball. Remember when we were at MGC looking at all the games?
This is like the only one for this Power Glove, isn't it?
Yeah, it was like $5, or it might have only been $2, so I bought it because I knew we were going to do this episode. So this game actually uses the positional data of the glove. When Karen was playing Mario earlier, it basically is like looking at left, right, up, down to move your character. But this actually has analog control.
Oh.
And I guess you can grab a ball.
Yeah, and it looked like you could go forward and backwards. Also, it had like a depth thing.
Yeah, we'll see if that works. I mean, in theory it should work because, you know, it would take less or more time for the sound to hit the speakers. If you notice, the lights are blinking very rapidly. So what I think is happening is instead of this simulating a controller, the Nintendo is polling this to get multiple bytes of data. So I think later on we can try to figure out what that data is.
Okay.
But for now, I'm going to play glove ball.
So there's lots of tiles. So you're supposed to make the tiles go, oh, you missed it. See, you are. If you look at your shadow.
Oh wait, I need to center.
So you can go forward and backwards because you can see your shadow is
It's going into the shot. Okay, I'm going to try to get that.
All right, so
question mark.
don't hit the green dudes, I guess.
What are those things anyway? Okay, now I've got it.
Little balls of fuzz that have arms and legs.
This music is so rare. This was clearly made by Rare. Oh! So when the ball turns green, that means it's in the foreground. Okay, there we go. I've got it in my hand, so it's got the finger grips or the bend sensors.
I think you want to hit the tiles with the question marks? Maybe those are like bonuses. I think you hit a green dude.
I think part of the problem with this is there's not that many sprites on the Nintendo, so you really can't do a whole lot of stuff.
Oh, you got multi-ball!
Multi-ball!
This game clearly uses physics.
Oh yes! The best physics 8 bits can simulate. So, Super Glove Ball, that was interesting.
Yeah, or you could use the word terrible.
Whoa, wait a minute. Are you wearing a glove over a glove?
Yes.
That's kind of like gloveception, isn't it?
Keeps my hands warm.
Okay, well, your hands should be really warm now with the Mattel Power Glove. But we did see analog motion on the screen, so it is sending out analog values. What I think we should do for this episode is first do a teardown of the Power Glove, see what's inside of it, see how it works. Then we could hook it up to the oscilloscope and look at the signals that is being sent to it and sent back from it to the Nintendo. Then finally, we can use those signals and analyze them to reverse engineer the protocol so we can talk to it with a microcontroller. And if we do that, then we can use the glove to do something else. Like it could be a joystick, or actually what would be kind of cool is like an in-air mouse, you know?
Be like, click, 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 Tom Cruise.
Yeah, like Minority Report. We're gonna solve all the murders. Let's get started. We're gonna have to tear that apart.
Gonna have to pry it from my cold gloved hand.
I think all the magic is gonna be inside this box, so I'm gonna start with it. You know, I've never seen the movie The Wizard. Quote unquote classic video game movie. I don't know why. I guess I just didn't care. I don't know, it's weird. Like, there's just some things like that I don't care about. Wow, not much in this. Well, let's look up these chips. Something tells me they're gonna be op amps. Yep, these are general purpose op amps. That's interesting. Maybe most of the brains are in the glove itself. Actually, there appears to be additional circuitry inside of these too. I miss the good old days when they were just regular old screws, and it's like, well, here's how you take it apart. Yeah, let's see what we got here. Oh yeah, receiver 1. That about sums it up. Do a quick part search here. I'm gonna guess another op amp, TL062CN. It is, yep, another op amp. What's this over here? This might be some sort of shift register to load the light bits. Yep, it's a shift register, all right. So the reason they'd use a shift register here is they have 6 lights, but they don't have enough wires to individually drive all those lights. So what they do is they shift the bits into this to use fewer wires in order to show the different lights. And that, once again, makes me think that there's more going on in the glove itself, because this is all pretty simple logic. So this chip here basically acts as a driver for these LEDs. And this is an op amp, which is taking what is received and amplifying it, and that gets further amplified over here, and then probably turned into some sort of signal the Nintendo can understand. So the Nintendo controller itself works like a shift register. You know, you have your plug here with 7 lines on it, so you might be like, oh, my controller has 8 buttons, 7 lines, how does that work? Well, it works by having a chip much like this one, but an input shift register. You set your 8 lines, like what buttons you're pushing, and then it clocks it 1, 2, 3, 4, 5, 6, 7, 8 times and gets the data out of it. That allows it to get multiple bits of data over a small connection. So I'm kind of guessing that there's also just, you know, this is going to be the same in here and here, so I'm not going to bother with that at the moment, because I'm even more curious as to what's in the glove itself. So we haven't found any logic so far that would allow you to set a program, you know, like program 5.6, I want to play Rad Racer or Battletoads. So my thought is that microcontroller, or it might be an ASIC laptop, is probably going to be inside the glove itself. There it is. Oh, it's a custom chip from Mattel. Well, that's not going to be very useful to us. But it's good though, because it shows that there's logic involved. So this is probably some kind of custom microcontroller. Man, there's a lot of wiring in this, look at that. Well, I'm glad this chip isn't a glop top. A glop top is where they put the integrated circuit directly onto the PCB to save money, and then they just put epoxy over it. It's cheap, but it's basically impossible to hack or do anything with. Oh yeah, this is just gonna be the button layer back here and an LED. Wow, they made a custom chip for this. Interesting. And we can try to look up the part number on this chip, but we probably won't find anything. It's pretty common with custom chips. They were designed for one thing by the company, and you know, they weren't meant for anyone else to use, so there's no data sheets out there. I'm just gonna put this back together for now. I've set everything up on my bench so I can look at the scope while I'm doing this. Looks like everything is working. Glove ball is still a horrible experience. Okay, so this is a pinout of the Nintendo's controller port, and there's actually a difference between the first port and the second port. The second port is where you put the light gun, and also on the Japanese Nintendo, the Famicom, which stands for Family Computer, there was a microphone port on the second controller as well. There's only 5 connections going to it, which I've pinned out right here. There's power, ground, clock, data, latch. So a regular Nintendo controller just has a single shift register in it. So what a shift register does, it allows you to control multiple inputs or outputs with a serial data line. That way you don't need as much I/O on your microcontroller or CPU. And so the Nintendo works the same way. The Nintendo CPU pulses the chip inside your controller, and the chip pulses back the 8 states of its switches. What I think happens with this is it still pulses it, but it pulses it multiple times to get multiple bytes of data. And then when the system boots up, it uses probably the latch line to send a special code to the Power Glove saying, hey, I'm a Power Glove game, go into special mode. So we can use the scope to figure that out. Okay, we're gonna test a normal game, Super Mario Brothers. Also a good game, unlike Super Glove Ball. Just because it has the word super in front of it doesn't make it good. I've got it hooked up to the scope so we can see what we can see. Okay, so channel 3 is the latch. On the Nintendo, you have to manually get the controller input from the program. So the programmer actually has to be like, boom, 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 pulse out the data and then look at the clocks. It's kind of clunky, but you know, those old systems were made to be as cheap as possible. And this is gonna be 5-volt TTL. Wow, those are really short clock pulses. I didn't expect that. 1, 2, 3, 4, 5, 6, 7, 8. I'm gonna set the Power Glove to just act as a normal controller, which is one of its built-in programs. That way we can make sure the data we're getting on the scope is correct. I'm gonna enter program 14 on the Power Glove, which will turn it into a normal controller. It's like it's pulsing it twice. Look at that, it's like sampling it twice. I wonder if it's, oh, it might be both controllers is what it's doing. Like it's actually trying to get both of them at once. That's possible. No, because it's doubling it up here and here. I wonder if it only samples the second controller if you put in a 2-player game. So this is the data line. So this is what the controller's sending back to it. Let's just map this out. So we've got start, B. So if we push them both at the same time, we can see, you know, how they interact with each other. So it's select, then start, select, start. B is right before select. A is before that. Okay, so see how I'm pushing the button so I can see the known position. Then I can push another button and see how it changes it. So up is after start, and I assume it's gonna be up, down, left, right. Yep, up, down, left, right. Man, those are such short clocks. It's not really what I expected. So this third signal here, that's latch. When that's pulsed high, it causes the data on the buttons to be latched into the internal register, and then the internal register is clocked into the Nintendo. So you can see it here on the scope. First, it says, give me the data, so there's the pulse, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, and counts to see how many pulses are high or low, and that's how it knows the state of the controller.
It's time for Felix's Corner. Hey, welcome to Felix's Corner. In today's episode, I'm doing a little bit of research on radio transmitters. We have an upcoming episode where we're going to build some robots, and Karen and Ben and I are going to battle it out. Right now, we're thinking about using some off-the-shelf transmitter receiver units. And this is the awesome Spectrum DXE. It works really great. We got it from our local hobby store. But I had some radio modules laying about, and I thought, hey, I would like to try these out. What I did is I hooked them up to 2 Arduinos, and I have an analog stick on one and a servo on the other. And basically, I take the analog signal here, transfer it to a byte, and send it to the other Arduino, which works as the receiver, and then that translates it into a signal for the servo. I guess it's got some example code on there. I'm gonna try and see if I can get more servos on and some other controls as well, so it's not just one, right, obviously. So yeah, that's pretty fun. That's as far as I've gotten so far. I'll see what other controls I can add, and I'll keep you posted.
And now, back to the build. Now we're going to try a Power Glove Gaming Series game, Super Glove Ball. I don't know if super is the word I would use. So somehow the glove knows that a Power Glove game is in the console, because if you look at the lights on the sensor bar, they're flickering rapidly now. And we have the analog control, which actually right now is actually not working too bad. So my guess is on the clock data latch line, some sort of special pulse is sent to tell the microcontroller inside of this glove that there's an actual Power Glove game, and that the glove should send out the positional data instead of just the dumb left, right, up, down, BA stuff. Because the glove by default just functions like a normal controller. It just sends out the 8 bits that we saw before. But, well, yeah, look at the scope here. Okay, let's watch what the scope does. Okay, so the game starts up. Now look at this. This is a lot more data than we saw with just a regular Nintendo controller. If you look over on the right, you can see bending the thumb is changing some bits. So we should be able to reverse engineer all these buttons and figure out what's going on. That would be cool. Oh yeah, okay, look at this. So obviously we don't know exactly what these are yet, but we can kind of guess. So with the first one appears to be some sort of synchronization pulse. The second one looks like it's left to right. The third one looks like it's up and down, and the fourth one looks like it's depth. I wonder if it knows rotation as well. I've got a Teensy 2.0 microcontroller here. I'd like to use it because we can use it as a HID, a human interface device. So possibly we could make a mouse out of the Power Glove if we're really lucky. We could redefine virtual reality for a new paradigm, age of enlightenment. So here's what I'm doing first. I wrote this code and it has an interrupt. An interrupt is a section of code that either triggers at a certain frequency or is triggered when there's an external input. So whatever your code is doing, it'll drop everything and jump to the interrupt service routine. In this case, we have one called get data. And we're doing the low level port access here to make it faster. And this is going to run about 60 times a second, just like the speed at which the Power Glove was sampled. And right now it's just going to clock in data, and we're going to clock in data from a standard Nintendo controller because it's kind of the same thing. And if we know that works, then we can move on to the Power Glove. All right, and this is going to print the results to the serial terminal. So I'm going to plug in the Nintendo controller and let's see what we can find. Okay, so the buttons are pulled up by default. So if we push buttons, oh, there we go. Right, left, down, up, start, select, B, A. Cool, there's all the buttons. If you recall when you're looking at the scope, the first bit of data is already there when you do the latch. So this is the latch. And then we get the first bit of data right there. So basically, if port B and the second bit is 1, then we add a 1 to the byte in. Then we build the next 8 bits. Well, the last one just gets pushed off the edge, but that's all right. And then we copy what we built into something called controller. The reason we do that is because this is an interrupt, so we don't always know when our main loop is going to be printing it. So if we, printed it halfway through, the byte might not be fully formed. Although that really shouldn't be a problem, but I'm still separating it just to be sure. Okay, so this works. I'll double check it by looking on the scope to make sure that it's the right frequency, although the frequency probably doesn't really matter that much. But something to keep in mind is with this controller, we're interfacing an integrated circuit, 4021 shift register. However, the Power Glove uses a microcontroller and it's using interrupts to see those pulses. And the reason we need to think about that is because there's probably a certain limit at which it can work. So I might actually have to slow down my program, otherwise it might be too fast for the Power Glove. Okay, I think I have it working. Let me show you what I've got. So this is the Teensy. I've hooked a Nintendo port up to it, so the Power Glove will think it's a Nintendo basically. Power Glove beeps when it turns on. Okay, so we can see this is the beginning state. The Teensy is sending out pulses basically like a normal controller would, or I should say a normal game would. It pulses the magenta latch line and then it gets 8 bits back. So by looking at the source code and cross-referencing what I captured off of Super Glove Ball with the oscilloscope, I was able to re-engineer the boot sequence. So I've got a button here on the Teensy. When I press it, it will start the sequence. So let's back out here. No, See, it just flew by there. See if we can get it. And you could hear the glove beep, which meant that it was programmed properly. So the glove beeps once when it turns on and a second time when it's been programmed. So what I did was I made sure that all of these matched the data from the actual glove ball game. And this is something where a scope is basically indispensable. Yep, everything matches up. And now if we go into the live view, we see the same thing as before when we first started looking at this, where we're pulsing it at approximately 60 hertz, and there are 2 null cycles and then a data cycle. So let's take a look at the data cycle. So the data cycle starts out like a normal null cycle, which is the first byte here, and then it speeds up a little bit. And the first byte always returns the same thing, which are these 4 bits. Then it speeds up a little bit, and this is the actual positional data. And I have that streaming on the computer. The first number is that, I don't know, sync packet, doesn't really mean anything. The second number looks like it's the X. Let's do this, let's center it. Okay, you can see the numbers change, that's cool. All right, let's go left and right. All right, so it looks like center is right around 255. I highly doubt this is signed because the Nintendo doesn't even have a decimal mode, let alone signed mode. That's where you can make numbers negatives. So if you have an 8-bit signed number, it goes from negative 128 to positive 127. Okay, so let's go to the right. All right, we see the first number. See how it rolls over from 255 down to 3, and now it's going back up again. You can actually get quite a ways off target before you actually lose it. That's pretty cool. See how I'm going like well past the sensors. Okay, so let's go back to the center. You go to the left, and now that second number goes down. So it goes down to about 130 before we start to lose the plot, and it goes up to about the same. It's basically, this is 255 to 130, and this is 0 to 130 is the X. Okay, let's try the Y, which is probably gonna be the third one. Okay, so again, yeah, if I center it, we're at roughly, see how they both go to 0 if I hold my hand really still, which I'm good at because I'm good at soldering. So if I go down, see how the number drops to 100, 170, again, it goes down to about 130. So let's go back up to the center. Now let's go up, rolls over to 0, goes up, 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 up. This one doesn't go quite as far. It's probably because I'm a little too close to this thing. Let's try it like this. So when you push the center button, that's all on the glove's logic. So when you're sensing the data, you don't have to worry about that, which is good. Yeah, it doesn't seem to be as much range up and down, probably because the sensors are side by side. My arm's already getting tired. I was never into the Wii. By the way, as everyone knows, I'm like a big Nintendo hater. Well, modern Nintendo. I love old Nintendo. Now the fourth number here, I think is probably gonna be the depth. Okay, so let's see, right now it's a 10 or a 9. Let's move my hand in. Okay, yeah, see how that one's decrementing? And again, it looks like 255 is probably the center point. So if I go forward, see how it rolls backwards from 255, and if I go back, I assume it's gonna go up to 0, roll over to 0, and then continue going like that. Yep. Now this fifth number, I don't know if that's rotation or what it is. It could also be the buttons, I don't know. Oh, here we go. Looks like that number is connected to the buttons here. I believe those are in a matrix of some sort. Oh, I pushed center again. I didn't mean to do that. Sorry. So yeah, I'm trying to figure out where the finger buttons are. I did notice in the code, if you move your hand in the extremity, it will reset the on and off position of the buttons. Okay, see how that one's going from 112 to 64? See, this one would make more sense if it's binary. It would either be on or off, so I could switch that to be a binary number. It's looking pretty good. So yeah, we have the X, the Y, the Z, and the fingers. Now I'm playing with power. One of the reasons I used a Teensy microcontroller is because it's really easy to turn it into a human interface device, a HID, such as a mouse. So I drew up this sheet of the positions that the Power Glove uses. So it doesn't use negative numbers, but it does use 1 byte for each direction. And so I wrote some code to map that into mouse positions, and now I can use it as the world's worst mouse. All right, so I'm gonna plug in the Teensy and get that programmed. All right, now I'm gonna put on this Power Glove. These microphones fit nicely on my monitors. I think I'll just leave them there forever because I don't know why I wouldn't want to use a Power Glove for everything. I mean, Salvador Dali, if he would have had a Power Glove, he would have used it. And those melted clocks would have looked even more melted. All right, so let's get this up here. It's not going to actually start emulating the mouse until I program the glove, which is via this button. Okay, so I'm streaming the XY position of the mouse. It's basically positive is to the right, negative is to the left, and for the Y, negative is up and positive is down. One thing I've definitely noticed with the Power Glove is its vertical positioning is a lot worse than its horizontal positioning, probably because there's only one vertical speaker. Now, a mouse works off of change, which is one of the reasons why it works so well. So like a mouse, you can pick up and move, but this you really can't. So, all right, I'm gonna try to draw some sweet Sonic the Hedgehog fan art, because why wouldn't I do that? Salvador the Hedgehog, which probably exists. Oh, whoa, okay, wait, all right. I think this could replace the mouse. Forget about virtual reality. This is the future. It is really hard to hold your hand perfectly steady. I guess I could have put a dead zone in this, but this drawing represents the conflict of man as he lives in his modern age of computers, and the computer has taken his soul and consumed it, and these marks represent his soul's transient progress across the fabric of time. Well, I didn't expect this to make a very good mouse, and I was right. Although this actually doesn't look as bad as some Sonic fan art out there. It's, I would say, middle of the road. You can't even see how bad it looks. It doesn't look like anything. It's cubist Sonic. Well, this thing is really inaccurate, but I did truly turn the Power Glove into a mouse. Now it's time for some shop talk. Boy, Karen, I tell you, building the Hackmanji game, thinking of the logic puzzles, it's a lot to deal with. If only there was someone that could help me.
You know, you don't have to be the one to come up with the logic puzzles. I bet we could get help from the community.
Oh yeah. So we made a video that tells you how to make logic puzzles for the Hackmanji game. If you click the link below, you can go to it and find out what to do.
So watch that video, learn a little bit about logic gates, and help us come up with some puzzles that we can use in our Jumanji board game.
The fate of Hackmanji is up to you. Well, that was fun. We reverse engineered the Power Glove, got some valid data off of it, and turned it into a mouse.
Ooh. Now a mouse is pretty simple. I bet our friends out on the internet have some bigger and better ideas for what we could have done with the Power Glove. So let us know on the Element 14 community what you would have used the Power Glove for.
It doesn't make me strong enough to crush things.
Doesn't look like it.
Darn it. Is there a pickle jar I could try to open? Actually, I think they actually tore down the Berlin Wall faster than you can complete a stage in this game. Oh man, it's hard to use a scope with a Power Glove on. It's hard to do anything with the Power Glove on, including playing games. High five! Ugh. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.